Suppose we want to get additional details from one specific client. That might be useful for troubleshooting, so let's learn how. Now that we've explored collecting the aggregated health stats of all clients, let's query some individual clients. We do this by specifying their MAC addresses. At the time of this recording, I haven't found an obvious way to get a list of clients by MAC address using the REST API. Instead, I logged into DNA Center and manually recorded a few MAC addresses. The screenshot shows a sample of some of the MAC addresses I found. To make testing easier, I've written a few bash scripts we'll explore later, so don't worry about memorizing these addresses. Let's begin by exploring the getClientDetail.py script. We are importing a lot of libraries here, some of which look familiar. The RE library stands for regular expression, and for those not familiar, I'll explain what that means when the time comes. The rest of the imports are things we've seen before. Once again, the beginning of the main function hasn't changed, so let's continue evaluating the script. Unlike the previous health scripts, this script accepts an arbitrary number of command line arguments, each one representing a MAC address. However, we want to ensure the MACs are well-formed and valid, so I wrote a helper function called getMACs to handle it. It takes in the argument vector and returns a list of valid MACs. Let's check out that function. First, let's perform a quick check to ensure the user entered at least 2 arguments, including the script name. If they didn't, we can print a usage message to provide guidance, then exit the program. Assuming they entered some arguments, we only want to accept the valid MAC addresses and ignore any bogus entries. The h2 variable is a Python regex pattern that matches digits 0 through 9, lowercase a through f, and uppercase a through f. This covers the full range of hexadecimal digits. It also looks for exactly 2 characters which form 1 byte. We then take this pattern and assemble it into a larger pattern containing all 6 bytes of the MAC address separated by colons. This is the format that DNA Center expects. The for loop steps over all the arguments in the argument vector except skips the first one using Python slicing. Remember, the first argument is the script name, which definitely will not be a valid MAC address. If the regex pattern matches the user input, the MAC is valid and is added to the MACs list. Once the loop is finished, we return the final MACs list, which contains valid MAC addresses. With our newly built list, we iterate over all the MACs to get client details for each. Remember the params dictionary from previous clips? We are going to add a new key named MAC address to it, which contains the specific MAC to test. This is another required query parameter. Then, we issue the GET request to the client detail URL. Here's a screenshot of the documentation page that provides the URL reference. Again, notice that both the timestamp and MAC address query parameters are required. Once the request is complete, we save the HTTP response body as JSON, then check for failure. If the request failed, print the error details and quit the program. You might be thinking this is a heavy-handed approach since we shouldn't quit the program if a single MAC fails. Normally I'd agree with you, but there is a specific lesson I'm trying to teach using this technique, so just bear with me. If the request succeeded, we can optionally print out the data returned. Let's have a look at an example of the data structure using the getClientDetail.json file in the data ref directory. This is another huge file that we won't scrub, but I'll jump down to some basic data that we can easily access. Here, we can see the IPv4 address, wireless frequency band, wireless channel, and some other client details. Feel free to explore this output more after the clip. Next, I perform basic JSON accessing to pull out a few bits of information like the IP address, basic wireless configuration, and wireless health. This includes the received signal strength indication and signal-to-noise ratio, which are RSSI and SNR respectively. This gives us a high-level picture of how the wireless client is performing. I don't want to manually type out MAC addresses, so I wrote a simple bash script to help us named testclients.sh. The script calls our getClientDetail Python code and passes in 8 additional arguments. One of them is clearly invalid and should be ignored. The other 7 are valid and should be processed. Let's run the script and observe the output. The script failed midway through due to a rate limit. We received an HTTP 429 response indicating too many requests. Looking into the details of the message, it says we can only issue 5 requests per minute, which is extremely slow. We'll tackle this problem in the next clip, but let's scroll up and see if we were able to collect the client data from the first 5 MACs. Not all 5 fit on the screen fully, but hopefully this proves that the first 5 requests did work and we were able to collect client details for those devices. Our bogus MAC was completely ignored as expected. Back to this error message. How do you think we should overcome this problem? Give it some thought, then tune in to the next clip for the solution.